Welcome to another episode of AyAyAyAi.
Ay, 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 ay.
Today we have Michael in the room, and we're gonna, have as many machine learning discussions as possible because we have the machine learning teacher who is teaching his students about machine learning. And looking forward to learning from you, Michael. Um, let's get started.
Awesome. Well, thanks for having me. So I figure you want me to introduce myself, right?
Absolutely.
Please tell us more
Awesome.
about yourself.
So I currently work in developer relations at Converge.io, which is a subsidiary of Intel. I previously worked at Ascale, which is the company behind the Ray project. It's a distributed computing framework. That was such a fun job. And I do a lot of teaching on the side as well. Before it was also my full-time job, I've created courses for Stanford's Continuing Studies program, machine learning.
wow.
I have, I think, 5 LinkedIn Learning classes now. I've taught at UC San Diego's Extension School. I've taught a little bit at boot camps, and so on and so forth. I've also done research on wearable devices and like data analysis from them. So I've done a lot of different things. Typically, I don't go too deep into subjects. I am very much a jack of all trades, master of none kind of
Right.
person.
Right. Amazing.
But it's definitely been a great journey.
Yeah, so none of us here will get lost because you'll be able to touch all the topics in all varieties of ways, so that we can understand it, right?
Yeah, ideally.
Yeah.
That's how I feel about Lucky because he's jack of all trade when it comes to cybersecurity. The range and depth of his expertise in cybersecurity is amazing. So when he talks cybersecurity, I actually understand most of it because he makes the relationship very clear, weeds them out and separates them out and say, this is not like the other one. This is this one right here.
But it's like for some reason it's like when you can know how to ride a bike, you can do it well, and like what you do in machine learning and I'm not sure deep learning, machine learning, and AI is something that you do well, and I'm sure you can just skip right through it, and I think that's where people want to hear more about what you do, or more about maybe the phases of maybe deep learning, machine learning, AI, how you see it, or more about maybe projects that you've done recently.
So I think the biggest thing about machine learning, deep learning, AI, like whatever you're doing, is about trying to solve the problem in hand.
Hmm.
Because oftentimes you get very much in the weeds about this specific algorithm, this specific enhancement, distilling a bigger model into a smaller one, basically transferring knowledge from something that's massive to smaller to be more efficient. There's a lot of different things in AI in general, but I think the problem is we always get focused on individual models and individual frameworks and individual advances. And that's great if you're purely into research or you're purely into talking about the news or whatever, but it's about the problem at hand, really.
Hmm.
And so as far as like problems I've solved or worked on, I've done a lot of work actually on like Fitbits back in the day. So I used to work at Scripps Research, and I did a lot of like Fitbit wearable analysis,
Oh
like
wow,
long-term trends in like sleep and heart rate and activity, and like a lot of that sort of work was very simple, data imputation. Well, relatively simple.
hmm
Looking at like simple things like if you know want to do an algorithm on something, you're missing data. Well, a big part of machine learning is actually having data that's applicable for machine learning. So
hmm
people have even done machine learning on data imputation. So if you think about it, it's very simple as I wear my Fitbit uh, on Monday and Wednesday, but on Tuesday I don't have a reading for my resting heart rate. Well, how would you get the value for that Tuesday you missed?
hmm
Well, that's a very simple imputation. It could be like a linear regression. It could be something else. You can do a model based on days of the week. You can do models based on, monthly cycles, hormonal cycles, whatever you want. Um, but oftentimes you do very simple stuff for a lot of occasions.
hmm
And then the cases where you need the big models are the Netflix of the world, the Googles of the world, where you have massive language models where having a fantastic model is very important, and taking time to train that model is not as big of a deal as in like smaller companies.
Yeah, so overfitting and underfitting, these sort of things, right? Like inside the model. So you're trying to solve a elephant size issue with a
Mm-hmm.
mosquito, or a mosquito size issue using an elephant, right?
Mm-hmm.
So these models, I think, whoever does it and however they come up with it over time, they will become essential not only for their business process but other people's business need, right?
Mm-hmm.
So if you have trained somebody to ride a bike, well, only that person can ride a bike. But if
Mm-hmm.
that model can ride a bike, now that
Yeah.
model can ride a bike for anybody who designs a model and
Mm-hmm.
incorporate that model to teach that model to ride a bike now, right?
Mm-hmm.
Mm-hmm.
So these are very important topics, like as in that under the hood kind of engine, right? Like what's in that black box? Like how are we operating all these scenarios, right? So we talk about automation in Tesla, we talk about automation in factories. This is
Mm-hmm.
sort of information that we need to have just to say, like, I know what that means. I don't get
Mm-hmm.
confused by it, because I get confused by it, I get threatened by it. I get
Mm-hmm.
threatened by it, I get angry about it, right? Which is technology 101. It happens
Mm-hmm.
so many times and so often that a lot of technology, even though they were perfectly good, just disappeared because people got threatened by it, right? And some technology that's lasted is because they were able to be transparent enough for the users to have like good understanding of it and say, like, look, even though I don't understand it, it doesn't threaten me, right?
Mm-hmm.
It's very important in that development of models and AI
Mm-hmm.
technology or product, whatever you want to call it, to have these sort of understanding. So we're going to have some great times learning from you, sir, because you're going to teach us how to, develop these models. How do you go
Oh
about it?
yeah.
Like, what's your first step? Like, what's that first thing that you ask yourself as a question
Okay,
once
so
the vision has
first,
been laid out?
first it's about the problem at hand, as I mentioned earlier. The second thing is, so like the problem at hand, it can be as simple as analyzing, is this a classification or
Mm-hmm.
regression test, right? In a very, very simple
Excuse me.
sort of way. There's other
Yeah.
sort of problems you can have, of course,
Mm-hmm.
but based on what kind of task you have, they could be like, okay, what kind of model, should I use? Do I have a natural language problem? Do I go to a transformer model because that's the cutting edge? Uh, if I have something that is very simple, like housing prices, well, the data is typically relatively simple if you just have a normal data set that isn't like industry based. So you can go
Mm-hmm.
to a gradient boosting sort of model to predict home prices, basically like a gradient boosting model for regression, essentially. So that's like the XGBoost of the world and so on and so forth. And then if I have, classification tasks, well, then you stick to a classification type of model. You can go for support vector machine. You can go for a logistic regression. You can go for a decision
Okay.
tree for classification, random forest, classify something, gradient boosting model again, of course. But it's about solving the problem, right? So you work backward
Mm-hmm.
from what you want, and then, how do you get there, right? And I think the other thing to consider is, if you're someone that's in industry and you want to actually put them on production, well, putting models into production are not always as, simple as just train a model on the data and then putting it
Mm-hmm.
out there. It has to be a model that is um, easy to upkeep, a model that can retrain quickly if that's what you need, a model that's easy to develop, a model that you can track experiments for to make sure that it's performing kind of how you like, to also see what you've done in the past. Some cases you need feature stores, which is like a completely different subject entirely than what we're talking about. Um, but there's a lot that goes into putting them on production that we probably not going to cover here today.
Yeah. No, I think it's interesting that you did the work with the Fitbit,
Mm-hmm.
and the tracking of the pulse.
Mm-hmm.
Because I had a prop. I'm a technology guy. I
Mm-hmm.
was my first system prior. You were '90s baby. I was playing with a Commodore 64 in the '80s,
Mm-hmm.
and so I love technology, but I have a respect for the peoples that use technology. So the Big Brother syndrome. So it starts with that. Then my girlfriend bought me an Apple Watch, which is similar to the
Mm-hmm.
Fitbit,
Yep.
and it has some of the same type of applications where I wore it and it woke me up. It didn't wake me; it alerted me the next day that I had a cardiac issue. And I
Mm-hmm.
said, well, you got to be kidding me. So I looked through the settings, figured it out. I was like, yeah, it's right. I have bradycardia.
Mm-hmm.
And it identified that in my sleep. And it was wild to see something like that actually working. You don't really diagnose yourself, but it's like now you're aware that there could be a problem. I think that's awesome that that type of stuff is being developed, and it's fantastic to meet somebody that helped gear or develop some of that technology. It's props to you, my friend. That's great work.
Thanks. I mean, it's a little different Apple versus Fitbit, but yeah, the same sort of. But as far as like just
Yeah,
analyzing data, I mean,
exactly. It,
oftentimes these things have features that can detect, AFib, bradycardia,
hmm
depending on what you're using. Um,
exactly.
it's a tool. If we use it properly, it can have a lot of value for people.
Yeah. Or did you have it to where it would look at like maybe possible that you were having some kind of MI or something, or did you just look at specific symptoms and say, all right, we're going to develop, like you said, either it's two different types of structures that you develop. One is more, I forget the two. Is one is more structured for tagging categories, and the other one's more for more developing some kind of algorithm or some kind of logic that develops. And I'm sorry,
Yeah,
I'm a little misunderstanding some of the stuff that you're providing, but I know
sure.
I.
So, it depends on the use case, of course, but
Hmm.
like looking at like AFib events, it's a lot of times that's, classifying whether you have an AFib event or not. Basically just a heart issue potentially.
Hmm.
And that's typically, assigning, do you have AFib or not? Is there a probability for that? Um,
Hmm.
for bradycardia, if I understand the condition properly, that's when your heart rate gets basically too slow, from what I can remember.
Yeah,
Hopefully, someone that's reading
exactly.
this is like, "Oh,
Yeah, yeah.
this is correct or this is wrong," right?
No, no, you hit it right
That's
on the nose. Yeah.
an easier thing I would argue to detect than like AFib, because if you're below a certain threshold, that's really just a simple kind of if else sort of logic, right?
Hmm.
Which is very valuable too. That's a very valuable thing. If your heart rate goes below a certain amount for a certain period of time, well, that may be something you should look into. Um,
Hmm.
it could be something that's perfectly fine. Some humans are probably perfectly healthy above or below a certain threshold, right?
Exactly.
Um, and
I
so
see.
it could be alerting someone, hey, this could potentially be an issue, like just once, and then that's it, right? So it's. Did you find it useful, by the way?
Oh yeah, it's fantastic. So I mean, just like say for myself, I was raised more in the security background,
Mm-hmm.
and so I worked a lot with IPSs and IDSs, and I engineered a lot of that market when I was a kid, and so I was part of. It feels good to be able to give something to the community, and it's nice to be able to find out. You meet people that have done certain parts and done certain things that are really cool, and that's something I'll remember. So that's
Mm-hmm.
awesome. But yeah, continuing, yeah, it's just learning from you is I'm an instructor also. What do you feel is the hardest part for people to kind of understand and grasp when they're trying to go from something from I don't know, from machine learning to AI, or from maybe deep learning to machine learning? What's the hardest thing to grasp there that you find with students?
Well, I think the biggest thing students lack is patience,
Oh,
but
okay.
that's
Oh
probably
my goodness.
another subject
Wait,
entirely.
you just talking about students or you talking about the rest of the world?
Everyone, just all over the place.
Everyone.
There's
Yeah.
a degree for urgency, which is very important. But as far as like learning, I think just taking one step after another. Like people always want to get to the algorithm, but they don't actually want to go to the cleaning the data or
Hmm.
finding a way to reproducibly get data, ingest data properly. There's those sort of things. Garbage in and garbage out is a big thing here with machine learning. In essence, the way a lot of people see it is if you have bad model that goes into data, or sorry, bad data that goes into a model, then you're not going to have good results. So I think the
Hmm.
biggest thing teaching people is making sure your data is good, making sure you have appropriate number of features, an appropriate number of rows, because not all algorithms fit all data, which is a very, very important thing. Um, and sometimes it could be simple things like adjusting columns from strings to numerics, because algorithms typically won't accept numerics for a lot of cases.
Mm-hmm.
It could be things like if you have too many features and you have less rows than number of columns, then a lot of algorithms aren't going to find that very valid. It's going to be hard to get the optimal model there. Some algorithms and some techniques, like PCA, for example, they expect you to have more rows than columns.
PCA?
We're not even going to get into that.
What's
Basically,
PCA though?
Dimensionality reduction. It's when you compress data, essentially.
Okay.
That's principal component analysis. There's a lot of things you can do with PCA, like analyze components based on variance and like a lot of different stuff, and eigenvalues and eigenvectors. There's a lot of it that goes into that. But the whole point of answering your question is really just you have to understand your data to be able to put into a model in some way, shape, or form. There's algorithms, there's clustering that can help you understand your data. And there's a lot of different techniques and a lot of statistical operations can perform on columns to kind of understand your data. But the biggest thing is making sure it's acceptable for machine learning algorithms.
Yeah, so I think when you mentioned patience, patience is something that we have to train people first before we talk about AI. Because look, ultimately, the stage that you just talked about, it sort of falls into between the concept development and technology scouting, right? So that technology scouting is the part where you're like, look, I have billions of data, rows of records that I have to work with. And these rows of records are just in one database. And I have thousands of different databases, and they all have billions of rows and records, right? So complexity just begins when you just address that one issue, right? So prior to that, what you need is that AI and AI training and education and the needs assessment, right? So if you have a needs assessment that turns into AI education and then turns into technology scouting or say concept development, then you have a journey to continue. Like say, for example, chapter 1 of the book, chapter 2 of the book, chapter 12 of the book, right?
Yeah.
After you finish chapter 12, now you start volume 2. AI is sophisticated because it performs to the level you need it to perform. Software, however, you can just leave it in your desktop and never use it, right? But that doesn't mean that software is gone. The software is the one that will give birth to the next level of AI. Software plus plus is what AI is, pretty much, in my opinion, right? Coding plus plus, programming plus plus is artificial intelligence, right? Because programming and coding and software can get you so far, right? And the reason I started with the word patience is because we had to wait this long to get to the point of software coding and programming. Now, when we talk about, hey, you need to be more patient with AI, conversation goes like, shut the door, let's get out of here. We're not talking anymore. Because I'm done waiting. We're done being patient. And of course, the false logic that comes to everybody's mind is right away is that like, okay, where's that AI robot that we've been promised since how long? I don't know, hundreds of years at this point. But that's the first topic that comes into people's mind is that like, okay, where's that robot? Where's all this fancy AI that I've been promised in the movies, right? So what you just said about patience and going through all the steps, it's so important because software you don't have to be responsible for. A software that's on a desktop installed, you don't have to be really responsible for it. I guess somehow you are responsible if you pay subscription monthly for it. But if it's just installed and never used, you never use it. But an AI, on the other hand, has that responsibility piece to it, right? It's responsibility. You have to maintain it. You have to trigger things as the things are progressing in the environment and production, right? So again, the patience is what has to be taught. And that concept of responsibility is so vital in AI because, yes, you can develop an AI and somebody could hijack it from you. Somebody could take that AI and do malicious things with it. Somebody could not even hijack it, but just be malicious and sabotage it for you, that it could turn into something like what he mentioned earlier about Zillow, about the housing issues that they had where they lost money, right? It's just that somebody probably didn't take their responsibility seriously, right? They said, Well, if it says yes, go with yes. Decision has been made by AI. Let it go, right? Let it have it. Um, so this AI education, I think, is the far most importance, right? As in, before you get into that concept, before you do that technology scouting, learn AI. Learn AI
Mhm.
how to differentiate between AI and the software, right?
Hmm.
Because you will need software lessons, not in so in depth, but you have to understand what AI will be able to do using that software, right?
Hmm.
So differentiate, then understand what the connections are, right? And then what are the responsibilities as the next level of ongoing, engagement with folks, like either you're a developer or you're a user or you're just an enthusiast who will invest tons of money into it.
Yeah.
Mhm.
I do think it's software and machine learning is very much intertwined a lot of times these days. Like it used to be maybe you can develop, machine learning algorithm, publish in a journal and, have someone else figure it out. But training a lot of these bigger models these days, you do need like software expertise. A lot of things require distributed computing, for example. And distributed computing is not always the most simple thing to do, just on your own, right? It takes a lot of expertise, a lot of understanding of how distributed systems work and training and all this sort of stuff. So there is more and more overlap these days, and a lot of people for like machine learning companies are hiring a lot more software people
Mhm.
because the model training, the data engineering, that sort of stuff is very software intensive skill wise. But learn the software is very important before you typically just go into the machine learning end of things, unless you're
Mhm.
doing something relatively simple that has a lot of value.
Yeah, yeah.
Yeah.
I work with data warehouse side of things. So when I say amount of data that we have,
Mhm.
to have this much data and have it sitting around really just being processed from one system to another and
Mhm.
just making a loop over and over really without having any data intelligence is a sad state of data right now, right? Data is
Mhm.
at motion, but data useless. Right?
Yeah,
Yeah.
um,
data is expensive too.
Data
You're
is
moving around
very
all
Yeah.
the time.
expensive, energy consuming. I think me and Lucky, we talked about it plenty of times. Is that the fact is you cannot sustain the way we have data and data physically stored in a server. It is
Yeah.
just not a sustainable model that we can have because you can only
Hmm.
build so many hardware for amount of data that you will build or collect over time. You
Hmm.
have to have a recycling process of data sooner or later, which
Mhm.
is that learn that data with AI, give that AI the content, have the AI build a context, and
Hmm.
within that context, AI will never need to save that data ever again.
Mhm.
Let go
Hmm.
of that data. I've learned it, let it go. There's no room for storing it. We shouldn't
Hmm.
store it anyway, right? Um, a fascinating innovation, I would say, if we can find a way to have an AI learn it all
Hmm.
and delete it all.
I mean, there is some of that sort of concepts with like edge computing, where
For sure.
you bring a model to data, stored in different areas, like healthcare, for example. You don't want the model, all the healthcare data being like one place, so you
Like
bring the
content
model to the
delivery,
data.
like
Um,
content delivery networks within cloud environments.
ooh, I don't not super familiar, but I would guess so. Yes,
Hmm.
but there's a lot of use cases for bring a model to data and then learn from it, then don't see the data again because like why?
So
It's
edge
expensive.
computing, Lucky, is like think about the cloud, and each corner
Hmm.
of a cloud you have an edge, right?
Exactly. Yeah. Yeah.
So if
Exactly.
you have edge computing, you have it on your zip code, right? And that zip code has certain amount of data that is ready and available for use. So when it comes to cybersecurity, right?
Yeah.
You don't access cloud system that is over in Virginia. You access it in Dallas, Texas,
Yeah. No. That I think that's.
and those are the systems that are established within your zip code. So it's not being traveling from Virginia back to your system.
No, I believe. Yeah, no, I understand. I believe that's called Content Delivery Network (CDN), cloud services. And no, yeah, I agree. Yeah, that's fantastic how that works. And in some cases, cloud vendors get in trouble because of that, because you have content and networking that's just wired together all over the world,
Hmm.
and it's not segmented out like we think it should be. It's more um, logically based as opposed to physically based. And so that
Mhm.
means it's all wired together through many protocols and redundant systems that if you're a government agency, I can't work with certain providers because the data is being replicated in so many places that it's only our requirements to say, for example, we want only to be replicated in the 48 states, terra firma. It's hard for cloud providers to deliver that, and typically because of that, the way they're developed or the way they're designed, the architecture is to be redundant and be
Mhm.
available.
I think that's a good problem to have, because
Hmm.
that means a lot of small business will be able to do so much business with the big cloud vendors that it okay, first of all,
Hmm.
um, I'm for all the small businesses, right? I want the small business to be involved in this
Little man.
data brokering and data vendoring, whatever the case is. Small business have to be part of it, because otherwise this control that you give away to somebody in Virginia is ridiculous, right? You got to have some
Hmm.
control over your access to that data, information availability, and integrity of that data within your site. Um, what you just mentioned gets super complex, because Jake, the Joint Artificial Intelligence Center that is built by Pentagon, one of their main priority is, how do we have edge computing in our Humvees, right?
Mhm.
So when a soldier is on the move, his internet is literally connected to his Humvee or his
Mhm.
helmet, right?
Satellite. Yeah.
So you're talking about transfer of data and the volume of data, the way that data has to travel. How do we minimize it to a level that is sustainable, right?
Mhm.
And is fast and has that CIA concept, right? Confidentiality, integrity, and availability. Um, yeah.
There's a
So
lot
talking
of
about from zip
problems
code
on this
to,
area.
yeah, one zip code to another zip code. Yeah, problem there. But now, how does it become a problem when you have to have a mobility of a
Yeah.
person
Mobility.
in his
Yeah.
helmet?
Mhm.
Yeah.
And these are just, challenges that are popping up more and more over time because there's more and more of these sort of problems. A lot of opportunity for, solving problems, of course, but it
Hmm.
creates computing problems, it can create privacy problems, creates all sorts of different problems, right? Um,
Yeah.
so I want to ask, so like, what are both of yours like top machine learning challenges that you deal with at work, or just I shouldn't say at work, or what you can share, I should say.
Batch processing. Batch processing is the single most use case that I'm like literally keeps me up at night, because they'll call 3 in the morning, say like, "Hey, something has failed." I'm like, what? How long have we been fixing this batch processing that it never fixes itself overnight?
Why does it fail though? Like, what's the
Simple,
problem
simple
missing?
data hashtag or some space that some user has entered by
Hmm.
faulty system errors. Simple
Hmm.
stuff. Nothing complicated. Like you just clean up two or three sets of record out of millions and millions of records that
Hmm.
came through last 4 hours, right?
Hmm.
Hmm. Uh, I, I I don't know. I mean, mine is a little different because I'm more of the curious, cat, because I where I come from is I ex developer. I've done a
Hmm.
few things. I've designed data warehouses back in early 2000s when there was considered data cubing, and analytics was different. They didn't have necessarily Microsoft analytic services. It was a whole different thing you had to do,
Star
and
schema.
it was complicated to do. But at the end, I understand the VA has gone, and other agencies, they use a lot of analytics,
Hmm.
but I really haven't seen the push. And I used to have a guy, his name was Herb Dollar. He was a old ISO at one of my hospitals, um, at the VA, and he always talked about artificial intelligence and how it's going to change this, and this is years ago. This sounds at least 10 years ago. So I'm still trying to figure out. Okay, so initially when analytics arrived in the early 2000s, it revolutionized the way business um, did things or made decisions for the most part. With analytics, hell, baseball teams changed the way they did things on drafted players.
Hmm.
I'm looking to see how AI or some type of machine learning is going to improve how to take care of veterans, or how that can improve. I'm trying to figure out, how that AI can help, or some kind of, how what's the next phase of helping people in medical care? Because that's my focus. Is yeah, I'm a cyber guy and I do a lot of this, but I've always looked at, I've always been in the medical field, or at least helping people, doctors,
Mhm.
physicians, in general. But at the end of the day, how is AI going? How can I leverage that to help people, veterans, and so, you know, just always trying to find the next best thing.
Mhm. Well,
And
I do have a couple thoughts on this as well, because I mean that's obviously a
mhm,
very, very complex and difficult problem, or at least we make it
mhm,
complex, right?
yeah,
Um, so have you ever like, how should I say this? I'm trying to say this nicely. So I think part of it is also there's a lot of room for simple analysis. Not even AI, like oh yeah, AI is going to change everything. But sometimes there's a lot of low hanging fruit in like
mhm,
analysis, right?
yeah,
So something could really just be finding ways to demonstrate through data or through data and through visuals that hey, maybe we need to train more doctors because maybe there's a certain amount of residencies that we have for doctors graduating medical school or whatever it is,
mhm,
and that's limited by Congress or Senate or whatever it is.
mhm,
Maybe just say we need more doctors to make it better for veterans so they can see more doctors, not to wait because oftentimes people that have health problems don't want to go through the medical system because it's complicated, right? Maybe just
mhm,
something as simple as like, hey, find out somehow how people are having trouble getting care and bring it more easily to them, right?
yeah,
Because oftentimes the simplest things are the most frustrating for people. We saw this during COVID where people had to get
mm,
vaccination cards and get them online sometimes, or fill out forms online. And oftentimes, a
yeah,
lot of people that are older may have had more trouble with that than younger generations, right? Um, so I think there's a lot of low hanging fruit that's not even just AI based that we could probably make life easier on people.
yeah. See,
So,
my focus was thinking, like, focusing, trying to get telehealth to get more automated analytics, because right
mm-hmm,
now telehealth is so new that telehealth is just, okay, right now, we get you a device, we get your, the status of where you're at, and then doctors review that. And I think there's a huge market with telehealth and automating things. And it's the only thing is scary there is, when is the AI making a decision and when is a doctor making a decision for the patient?
mm-hmm,
But I think there's a lot of opportunity there, you
Uh,
know.
If if I can, I want to take something that exists between our ears and
Yeah,
say,
yeah,
how do we augment this brain of ours with AI? Right? As in,
yeah.
if you can augment this brain, it's possible,
Neural
right?
net.
Neural network, right? So this brain that we have
Wow.
can be augmented by a computer, but the way that people look at it is opposite. They look at the
mm-hmm,
computer as the brain and
mm-hmm,
us as the victim of it, right? As in a computer, no matter if you build about 30 million computers and jumble them together, they
mm-hmm,
could never replicate a human brain.
mm-hmm,
And that's what most people have ideas about. Is that like, well, instead of using our brain, we will use the brain outside of ourselves to have this brain go dumb or if something bad happens to this human body. People get threatened by it, right? We
Well,
talk
hell
about
yeah, that sounds awesome. Autopilot.
autopilot, right? But I think the reality is that you can never sustain
Great.
enough amount of hardware to build that brain outside of our body. What we have
Yeah.
to understand is that this brain needs augmenting. And one good example of augmenting a brain is to say, if
Mhm.
your brain has been trained to become a doctor for so many years, and you
I
see
love that.
patients, 100 patients a day. No, you don't do that. I think it's
mm-hmm,
20 as average for a doctor to see. Sometimes they see 40, right?
mm-hmm,
But if you're seeing on a daily basis, you're seeing that many patients and you're having that much conversation, you need your brain to be augmented to perform to the level that you need it to. Because handling 5 people for me is difficult. I don't understand how doctors do it 20 a day, right? Like I'm having this three-way conversation right now. I'm like, this is it. After this, I'm done. I'm
mm-hmm,
quitting, right? But for doctors, it's not the case. What
Yeah.
needs to happen is that their brain needs to be augmented by an artificial intelligence to help them to do their task. And how do you do that? Like, well, one of the examples we have right now is that there's been a recording system that is being implemented between a patient and a doctor, physical, in person, or over the phone, or over the telecommunications, however, Zoom or Teledoc. Um, that recording system records the whole conversation, takes notes. Simple use case of just taking notes. Like, take
Mhm.
notes to the point that you can articulate the fact that this note is important, but this is not, right? This is not important because he's talking about his grandchildren, right?
Mhm.
But if he's talking about his health problem, now this gets, like bold letters, italic means it's not really that necessary. But human eyes will go over it and say, like, the grandkid stuff is probably a little bit important. Let's make it bold. So that's the ultimate first use case, the steps towards that,
Wow.
big giant use case, which is to say,
Mhm.
how do I augment a human doctor with AI now? Because as a person is taking notes, they don't really have to focus on taking notes. They can more think about like detecting the problem or helping the AI to detect the problem and come up with a solution.
Yeah.
Right. So that first step is to just take notes by a system that will learn from itself using a machine learning technology. And then right now we're doing that. Actually, we're taking notes, and what we're doing is using human eyes to look through those notes and say, like, okay, figure out what we're missing. Right. So that's that kind of supervised learning that has been being taught in schools, and that's what's being used right now in many of those fancy technologies. But think about that for a small case, right? Um, but obstacle behind it, what Michael just mentioned, is that we have a PII system that's put in place that doesn't allow us to just freely say, let's record a patient and a doctor conversation, right? Not that it's a bad thing, not that the regulation is bad, but the regulation is so outdated, it hasn't
Mhm.
really caught up to the issues of 2022, post 2020 COVID, right?
Yeah, yeah.
The
The world's
situation
changed
You have a point.
completely.
the situation is more complex than ever before. Um, so that's just a one use case of what you can do in healthcare side of things, that you can develop an AI to augment a human performance, right? And
Mhm.
and the reason I think a lot of the things are slowing down is because the other version of AI is what's coming into play in most people's understanding of AI. So that's why we need to have this conversation all the time. We need to have this understanding of people to say, like, look, it's augmenting a brain, not literally taking a brain and turning it into another brain, right? It's not like we're developing another brain using 30 million computers and jumbling them all
Oh.
together. Now they're a
hmm
big giant robot, right? And slapping Will Smith around or something like that,
No, see, I was thinking it was more like Neo, where he comes out of being in the asleep, and they plug him in, and all of a sudden he understands uh, not Tai Chi,
Kung Fu.
Kung Fu.
Cool.
Yeah.
Yeah.
Yeah, like
Well,
that's what I'm talking about.
let me not bring up Neuralink. I think Michael can testify to Neuralink, which literally is the capability of plugging some wires on the back of your head and having a Bluetooth device talk to a system, right?
Wow.
Yeah, yeah. Let's not go there today.
That's it's a little bit ways off, but we'll see. I want to go back to the augmenting doctors. I think people are
Yes.
also worried like, oh, a doctor's not going to see my form or this or that, and there's risks of everything. But
Right.
for a lot of like annotating doctor's notes, there's a lot of value in that because a lot of times doctors see one patient after another, after another, after another. They don't have time to do their medical records till like the end of the day sometimes or hours later because they
Yeah.
saw 12 patients in a row. So even just having the notes, be made so that they can do medical records later on is very valuable, right? So there's a lot of value in just what we consider simple things,
Mhm.
but just having cues from memory are very useful as well for the doctors later on.
That's right. That's
So
right. I'll tell you one thing that I was thinking about when we talked about complexity. Look,
mhm,
I'll get a little bit philosophical, and I'll give you a little background into that. Right. The reason I'm getting a little philosophical with this is because
mhm,
I look at it from a conflict resolution perspective. Right. That's what I coach people on. I coach people on conflict resolution, mostly negotiations, and trying to help them understand how they can become better mediator than a negotiator. because being a negotiator comes with a whole lot of practice, but mediation doesn't take that much of a practice, right? And mediation is active listening. And once you are an active listener, you can do much more with any conflict that you're dealing with. So here's my take on the complexity. We really, as human beings that has a brain between our ears, we only have one problem, right? And all the other problems still exist in the back of our head somewhere, because this problem really doesn't exist in an environment. Like the nature, the way, well, we are nature too, but the nature is not losing any ground because the humans have problems in their head, right? Nature is just whatever. I'm not conscious being. I'm not really thinking about problems. All I have is solutions. The nature is just full of solutions. If you look outside of yourself, it's all solutions. And we think like we have thousands of problems. Well, we actually have thousands of problems on a listing, but we only deal with one problem at a time. Right? And the reason I bring that up is because that one use case at a time is the best way to go about it. Pick that small use case that you can do today, maybe tomorrow, right? Or if not tomorrow, within the next 6 months.
Yeah.
But a lot of the companies are looking at AI like, well, I'm so far behind. I have to just jump right into the robots. Right? I just have to jump into that big set of data that I have to go out there and buy, right? Forgetting the fact that you have an organization full of people, and these people are your best tools in order to develop an AI process. And within that AI process, you can develop a technology that fits your business narrative much better than a narrative that you can buy from somewhere else, right? So if you think about it like from a one problem perspective, millions of solutions, you look at that one problem and say, one small use case, what is it, right? And then try to figure that out. Like it's like, for me, the batch processing, one simple error could have been RPA'd, right? Robotic process automation, like RPA to say like, write a code and say, if there's a simple space here, don't call me, right? Fix it yourself, delete it, right? And now I'm not putting it that simplistically, but think about it, right? If that was the problem, that would be the solution. That's a simple use case that we can work off of and say, how do we teach a machine to correct this error from billions of sets of rows and columns, right? So let's say, for example, if you have some information that is missing, how do I fill that information in? Or how do I take care of information that is false and remove that or tag it somehow, right? Sort of classification training. So machine learning in simplicity is that, you're looking for true positive, false negative, and true. Which one am I missing here? Like, you get my point. It's a quadrant. Literally in a 4-quadrant, you can figure out like, are you right? How right are you? Are you right to the 99%? Can I get you to 99% and have you perform at 99% all the times? Simple as that. Start with a simple use case and move on with AI. But
simple
a lot
use
of
case,
organizations
simple
are
metrics.
coming at it from the other side.
Yeah, I think that's in general though. People always want to promise a lot, and then because that's how you get sales for like, at least for like salespeople. It's like, oh yeah, we can solve every one of your problems immediately. Like we have all the solutions here. It'll be super cheap, and then like you'll end up having things are way over budget, way under delivered, and I think it's a human problem now.
Yeah. And that's what me and Lucky, we started talking to each other about how to go in front of these decision makers and sit down with the decision makers and the developers or the designers or the business process owners, data owners, whoever the case is. Sit down and just have this one-on-one topic of conversation. Say like, look, where you start is data structuring. And if you're not data structuring today, don't even talk about AI, right? If your data is failing and you don't have your data structured very well, don't think about AI, but don't jump into it today, because that's what's important right now. And who you need right now is already in this room, right? There's these IT developers, there's people that are working with your data, the data owners, the business process owners. They can all get together and fix that issue by addressing like, okay, if we structure our data today, how do we structure the data for an algorithm? So that way algorithm is not spitting out a bunch of garbage. We're not feeding that algorithm some garbage. We're feeding it some structured data that even if it's tweak it, even if the parameter have to be adjusted and tuned, we can do it without, really getting frustrated about the algorithm, because it's not algorithm's job to figure out what a bad data looks like. It's the business process owner, the data owners, the IT guys in the organization that can come up with a solution to that, right?
Unless your algorithm is specifically looking for bad data, like, and you could structure an algorithm like that, but yeah, for the most part, yeah, totally.
It just makes sense that you start with that small data structure that you've been building for so long.
Yeah.
Right.
I mean,
don't introduce a new tire because you need a new car, right?
Yeah. I think a lot of times, yeah, there's a lot other problems you can want to solve first before you solve some giant machine learning problem, or try to take over Google's this algorithm, that algorithm, or come up with next GPT model or whatever. And really, you just need something pretty small. You need some good data first before you do anything, and then go from there. But it goes back to patience, right? Like, are you able to have some modicum of patience to be able to get something done so they can do greater things down the road, right? Especially with companies that are very old fashioned, that like all of a sudden, 2022, like we got to get machine learning in our company. It's like, well, do you have data that's nice?
So the VA's effort right now for AI is to prevent a veteran suicide. Grand ambition, right? Very grand ambition. And they have a lot of NAIC, I think it's NAIC, is it's the VA's effort in AI, right? That's called Vinci. VINCI is the VA specific AI. Trying to solve AI problems, suicide issues in the veterans community. And I'm a veteran myself, so I understand the ambition and the goal. But I always wondered to myself, like, Da Vinci would have been a good use case if they would have fixed their like procurement process, that process that is tracking sort of like that acquisition process, right? That you're acquiring new technologies. How do you use AI for that, right? I look at AI from the data side of things first, right? If you can look at data and utilize that data to develop an AI, rather than to say like, I'm just going to take this AI and solve an issue. It's like, no, go backward. Start with data. That data that is dirty and not really structured and it's all over the place. And the conversation doesn't end there, right? It blows up when I say, you have billions of sets of rows of records. You have thousands of servers. You need a few more thousand servers and few more billions of rows and records of data. Because that's not enough. Whatever data that you're so proud of is still not enough. You might need a larger set of data to merge it against and test it out, right? See how structured is it.
You might need more data. You might need, cleaner data obviously is what you're going for there.
Right. Quality data, not the quantity of data. You need the quality of data. That's what you're looking for.
The quality could just be like, you can have enough rows. There is a lot of work these days with transfer learning, where you take some model that learned from a slightly different problem, then transfer that learning over, so you need less data for a lot of like complex things. But even then, a lot of it is the more data you have, the more you can do with it, right? So it's accessibility of data too. A lot of times people are like, oh, we have all this data, but you might not have access to that data, right? I think that's also a big problem you probably have in like confidential data, where a team's like, oh yeah, we're gonna do some machine learning, model, but this other team has access to the data and you can't get access to the data because of privacy concerns or whatever. So I think people before like, oh, we have this grand ambition for machine learning. It's like, well, do people have access to that data? Like, is it possible?
Big brother. You're helping develop Big Brother.
Well, how about
what's wrong with you?
How about for the next conversation, we talk about synthetic data, which could be a solution to the problem we just mentioned. And also, we got to hit up Neuralink, because Neuralink is so fascinating, in my opinion. I think it has big potential that, even we will resist it for a bit, but at one point or another, we'll understand how important it is that we are able to augment our brain, which has tremendous capacity. It just doesn't have tremendous capabilities, right? It has capacity, but it doesn't really have the capabilities, So with that said, I think this topic is amazing. We would love to continue that. Maybe we'll talk neural network the next segment too. And maybe Michael will come back and join us.
I'm happy to join whenever. I really
Yeah.
appreciate you having me too.
Yeah, I can only see like version 2 where they say, okay, Neuralink, it's overheating people. We're gonna have to add a fan.
See,
Yeah, we have to add fans to cool your brain because we're overheating you.
I'm gonna use that next time for Neuralink.
No, but yeah, I agree. It was a pleasure having you on. Did time already pass? Oh my gosh!
Yeah, we're pretty fast here.
Wow, wow, that was amazing. I did learn quite a bit. Thank you.
Me as
But
well.
before you go, we gotta do the AyAyAyAi on your voice, like as in we gotta hear it.
Oh yeah, we got to hear it.
Hopefully, I don't butcher it, right? Ay.
Hey
Okay,
man, that's good.
one more time.
No, that was good. But there you go.
Now, Lucky, you do it right.
Almost like you're Indian, like you want to reach into some ancestral like Indian roots or
right.
something.
I'm not going to go down that path. I can try, but it's not somewhere I'm going to go. But yeah.
Well, Michael, Lucky, it's always a pleasure. I'm looking forward to the next call, next conversation, because you know, every time we talk about this AI stuff, something new comes up, and
yeah,
we learn something new every time. And thanks for joining. Thanks for spending that 1 hour with us on a Wednesday, middle of the week.
Oh yeah,
I appreciate you guys so much.
Thank you so much, and thanks for having me. And I'd love to come on again. Bye.
All right, take care.
Bye bye.